Assalamu alaikum. In this series, Mr. Omar will guide you through some practice problems to cover all items included in the coverage issued by Emirate Schools Establishment, E.S.E. This is part 1. Have a fruitful time.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Welcome to this new series about the preparation of exam of physics term 2 year 23-24 according to the coverage sent by the E.S.E for class 11 advanced. This series will consist of many parts. In each part we will discuss some questions related to the coverage. Let's go. For the first goal in the coverage, we need to use the free body diagrams to solve some problems, including forces and motions. To achieve this, let's start with example 4.9, page 118 in your textbook. Suppose you are pulling a sled across a level snow covered surface. If the questions tell you that we have a level ground, so we conclude from that that is a horizontal surface. Even though the question is not saying that, we will understand it by the definition. Now, how we will pull that? By exerting a constant force on a rope at an angle of theta relative to the ground. So we have a rope with an angle theta with the ground. Now, since we know the surface is horizontal, then we will draw a horizontal surface. On that surface we will put some shape for the object, then draw x-axis parallel to the surface and y-axis normal or perpendicular to the surface, and these two axes will cross on the object. After that, put the weight. It is downward. This is the weight, and against the weight we have the normal force of normal. Then, as the question told us, there is a pulling force inclined with an angle of theta. This is the pulling force Fa, and this is the angle theta. Now we will continue with reading the question to see what information included in this question. If the sled, including its load, has a mass of 15.3, so this is the mass, and from the mass we can get the weight. The mass is 15.3 kilograms. Then we can find the weight, Fg equals mg, and we can find its magnitude by substituting 9.8 for the gravity. Then the answer will be for the weight 15.3 multiplied by 9.8. It is almost 149.94 newtons. The coefficient of friction coefficients, so we have μs and μk. Between the sled and the snow are μs and μk, and you pull with a force of 25.3. This is Fa on the rope at an angle of 24.5, this is theta, relative to the ground. What is the sled's acceleration? First of all, we need to find the frictional force, the static frictional force, and the kinetic frictional force, and compare it with the pulling force. Why is that? Follow me to see why is that. First of all, we put a direction to be positive if the motion is to the right. So the right is positive and the friction will be in the opposite direction on the x-axis. This is the friction. I will not name it Fs maximum or Fk, static or kinetic. It's just frictional force. Now, before continuing the solution, you need to resolve the forces, the inclined forces, which is Fa. Here we have Fax on the x direction and Fay. Fax equals Fa cosine theta and Fay equals Fa sine theta. Since the angle theta is with the x-axis, so the x-axis is the adjacent, so the component on x-axis will be in cosine, and for the y component it is into sine theta. Find the values for that. Fa, it is 25.3 cosine, the angle is 24.5, and for the y component 25.3 sine 24.5, and the values will be for Fax 23 and for Fay it is almost 10.5. Now apply the equilibrium condition on y-axis. On y-axis, we have F net on y-axis equals 0. This is the equilibrium condition. And we apply it on y-axis since there is no motion in the y direction. Go back to the free body diagram here. You will see that Fn, it is in the positive y-axis, and add to it Fay plus the force in the negative y direction, so it is minus Fg equals 0. For this we will find the normal force. F normal equals Fg minus Fay. Fg, it is 149.94 minus Fay, it is 10.5, and the answer is 139.4. newtons. Since we have now the normal force, we can easily find the two frictional force, Fs maximum and Fk. Fs maximum, which is static friction, it is mu s times Fn, and the kinetic friction Fk, it is mu k times Fn. Mu s and mu k are in the question 0.076 and 0.070. So substitute here 0.076 times the normal force 139.4, and the answer will be 10.6 newtons. And for the kinetic friction, it is 0.07 times 139.4, and the answer will be 9.758 newtons. Here we need to compare the frictional force, the two frictional force, with Fa maximum. What is the motive force? Fax, it will put the object into motion. We see that the Fs maximum is less than Fax. Is less than Fax. So the sled start to move with some acceleration. And this acceleration will not be zero. This is a very important step in solving such questions. Before proceeding with the question, examine the Fs maximum with the motive force Fax. If it is less than that, there will be a motion and there will be an acceleration. Suppose that, imagine that, it is just imagine that Fs maximum is greater than the motive force Fax. Immediately you will see no motion and the acceleration will be zero, and you will finish with this question. Okay? So exceeding this condition, it is a very important condition to proceed with the question. If Fs maximum is greater than Fax, the object will not move. Even though if Fax is greater than Fk, this is not a condition for motion. To start a motion, Fax should be larger than Fs maximum. Please, I want to erase this, but keep it in your mind. Don't forget this idea. Now we can proceed with the question, or we can start solving the question. Now, for x-axis, on x-axis, we will apply Newton's second law. I discussed this question with you in details, and I will use all this information in any question like that without more explanation. Okay, so please understand this question in good way. So on x-axis, Newton's second law says that F net on x-axis equals m times a. Now, what are the forces on the x-axis? For this free body diagram, we have Fax to the right and the frictional force to the left. And now, since we applying Newton's second law, we will use the kinetic friction, not the static friction, because we are now certain that the object will be moved. So will be in motion. So we will use the kinetic frictional forces, Fx to the right and Fk to the left. So put here Fa in the x direction minus Fk equals m times a. Now I will not put numbers. Fax, it is Fa cosine theta minus Fk from the previous step. Fk, it is mu k Fn, and Fn, it is only Fg minus Fay. So for Fk, we will put mu k times Fn equals m times a. Fa cosine theta minus mu k. Fn, it is Fg minus Fay equals m times a. Now Fa cosine theta minus mu k. For Fg we will put mg minus for Fay we have Fa sine theta equals m times a. Now we will distribute mu k here. Fa cosine theta minus mu k mg plus mu k Fa sine theta equals m times a. Now we can take Fa common factor. We have here cosine theta, and from that one we will have plus mu k sine theta, then minus mu k mg. All of this is equal to ma. We can put it here, ma. And now divide by m. We will have a equals Fa over m cosine theta plus mu k sine theta minus mu k mg over m. We divide both terms, this one and that one, on m to get the acceleration. Now we can cancel from here m, and the acceleration will be Fa over m cosine theta plus mu k sine theta minus mu k times g. Now we can substitute our numbers to find the acceleration. Mu k, it is 0.07, theta equals 24.5, and the force is 25.3. Put these numbers here. Fa 25.3. The mass is 15.3, I think. Yes, 15.3. Cosine 24.5 for the angle plus mu k 0.07 sine 24.5 minus mu k 0.07 times the gravity 9.8, and the answer will be something like 0.8667 and some digits here, one. Okay. In our questions we have three significant figures, so we can write it as 0.867 meter per second square. Why we solve the question in such a way? Because I know the question needs something else. We can use by numbers. It would be very easy from here. It's very easy. Why? F(ax) we have it, Fk we have it, and we can find A easily by numbers from here. Because F(ax) is 23. If you want to solve immediately by numbers here, okay, no problem. F(x) is 23 minus Fk, it is 9.758 equals 15.3 times A, and you will get A from here. 23 minus 9.758 divided by 15.3, it is 0.865 meter per second square. Here is some differences because we have here some rounding here, some rounding here. We have many roundings, so it is different than this one. This one has no rounding, or the least rounding we can do. Okay, so for finding A, it's very easy from this step if you use numbers. But why I solve like this? Because there is another thing in the question and problem number 2. Let's go to that part. Now problem number 2 says, what angle of the rod with the horizontal will produce a maximum acceleration? We need A to be maximum. So to maximize the acceleration, we need to find an equation for the acceleration with respect to theta, because the question asks about theta. What is the angle? So we need to find A as a function of theta. Then derive it and use the first derivative test, like I will show you here. Now the acceleration as a function of theta, we produce it here. A equals Fa over m cosine theta plus mu k sine theta minus mu k j. So this is why we solve question number 1 by this procedure, not by numbers as I mentioned here. Okay. So I have the acceleration as a function of theta. It is A equals F over m cosine theta plus mu k sine theta minus mu k times g. Now let us take the derivative of A with respect to theta, dA by d theta equals F over m. It is a constant, it is not a function of theta. The derivative of cosine theta, it is minus sine theta, and the derivative of theta is 1, plus mu k, it is a number, constant. The derivative of sine, it is cosine theta, minus mu kg, it is a constant, so the derivative of it with respect to theta is 0. So here we have d by d theta for the sine is cosine theta, and d by d theta for the cosine theta, it is minus sine theta. Now we found our derivative of the acceleration with respect to theta. Now to maximize the acceleration, put this derivative equal to 0. This is the procedure named as first derivative test, as we mentioned earlier. First derivative test. Now putting dA by d theta equals 0, I mean this will be put to be 0. So f over m minus sine theta plus mu k cosine theta should be equals to 0 for maximizing the acceleration. So for maximizing the acceleration. If this is equal to 0, then even f over m equals 0 or minus sine theta plus mu k cosine theta equals 0. For the first one, this is to be 0. We have two solutions, f equals 0 or the mass is infinity. And they are trivial. They are trivial solutions. And these two solutions means there's no motion. No motion. Since there is no force and or the mass is infinity, so we cannot make or set the object to be in motion. Now we will go to the other one. If minus sine theta plus mu k, cosine theta equals 0, that means mu k cosine theta should be equal to sine theta. And that means mu k, let's go to the next page. That means mu k cosine theta equals sine theta. Mu k equals sine theta over cosine theta, which is tan theta. And theta here it is tan inverse of the mu k. This is our solution. Find it, tan inverse. Mu k it is 0.07. So shift tan 0.07. The answer is 4. So if the angle is 4 degrees, the acceleration may be maximum. How can we be certain of that? Put the axis of theta and put here theta equals 4. Take any number greater than 4 degrees or less. I will take 0 here and put it back in the equation of the derivative here. If you put here 0 and here 0, sine 0 is 0, so this will be 0. Sine 0 is 1. 1 times mu k, it is mu k, so it is a positive number. So d theta, d alpha by d theta, if theta is 0, is positive. So in this area we have positive numbers for the derivative. And here negative numbers. So this is dA by d theta. This is the sign of dA by d theta. The positive means increasing, then here negative means decreasing. So at theta equals 4, we have a maximum. which is what we are seeking. Now, what is the maximum acceleration? The maximum acceleration is the acceleration at theta equals theta maximum, which is 4. Here we need to put the equation for the acceleration. This equation, the acceleration F over m cosine theta plus mu k sine theta minus mu k times g. So put here F over a, Fa over m, then cosine theta plus mu sine theta minus mu k times g. And we need to put theta equals 4. Fa it is 24.5 0.3, I think. See what is the 25.3, 25.3 the mass is 15.3 cosine the angle which maximizes the acceleration is 4 plus mu k 0.07 sine theta is 4, this is the theta that maximizes the acceleration, minus mu k 0.07 times the acceleration due gravity is 9.8. Find the answer by your calculator. It is 0.971 or 2, by rounding, meter per second square. It is the maximum acceleration using Fa equals 25.3 in Newton. Okay? This is the question. This is a very big question. I know. If you read my opinion, I don't think they will give you such a question in the exam. But since they mention it in the coverage, I explain it for you. Okay? They mention it in the coverage, so I have to explain it for you. But in my opinion, I don't think that they will bring it in the exam. Okay, this is the first question. Before we continue with the rest of questions, I will only discuss the mentioned questions by the coverage. Okay? Now we are going to question number 2. It is in the book, page 129. The question is 4.92, branch A. A block of mass M1 equals 2.3 kilogram is placed in front of a block of mass M2 5.2 kilogram as shown in the figure. So here M1 and M2. M1 it is in the blue and M2 in the gray color. The coefficient of static friction between M1 and M2 is 0.65 and there is no negligible friction between the larger block and the tabletop. What forces are acting on M1? We need to find the forces acting on M1, so we need to draw the free body diagram for M1. If you go to this figure, you see that there is a force pushing M2 here. So M2 will push M1 with a force. Let us name it as N to 1. Normal force from 2 to 1. according to Newton's third law, M1 will push back M2 to the right with a force, normal force, 1, 2. And according to Newton's third law, N12 equals N21, but in the opposite direction. So in vectorial notation, N12 as a vector is minus N21 as a vector. Now, what other forces in our system? We have Fg here, downward, Fg2, and a normal force on M2 from the table up here, N2. And we have the weight of M1 is downward, Fg. That's it. So what are forces acting on M1? If we draw the free body diagram for M1, we find that there is Fg downward, and to the right we have, to the left, sorry, the pushing force from M2, which is the normal force between them, N21. Now, this N21 gives M1 its acceleration, okay? But Fg1 will pull M1 downward, so M1 will fall. But it is not falling. So there is something missing. The missing is we have here frictional force between the surface up, and we name it as Fs maximum static friction, or Fs, maybe it is not maximum. So we have other forces that will put M1 in an vertical equilibrium against the gravity. So here we have Fs, and we know that Fs equals Fg1, which is M1 times G. We can solve for it. M1 is 2.3 times G, 9.8. 2.3 times 9.8, it is 22.54. Now, N21 should be M1 times the acceleration. And if you need to find the acceleration is the force that put the system in motion, which is F, divided by the two masses M1 plus M2. Put it here, M1 over M1 plus M2 times F. This is N21. The question didn't give me F, so I cannot find a numerical value for N21. But as free body diagram, this is the free body diagram for M1, which is needed by this. What forces are acting on M1? M1 is affected by three forces. The gravity will pull it down, Fg1. Against the gravity, there is a static friction to prevent motion in the vertical direction. And we have N21, which is the force that M2 pull M1 to the left. The numerical value of Fs, it is 22.45. The numerical value for N21, it is M1 over M1 plus M2 times F. If the question gives me F, I will find N2 easily. This is for this question. I will stop here. Only one question or two questions. That's enough for part 1. See you in part 2.
I hope that this video has enriched you more. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of part 1. See you in part 2. Salam.